will start about the introduction to Verilog. Introduction to Verilog. So basically, like if you see any programming languages, okay. So programming languages, there are two types are there. One is software programming language, software programming language, and hardware descriptive language, hardware descriptive language. So software programming languages are like you have C, C++, and Java and Python. These are nothing but some software programming languages. And hardware descriptive languages, that's HDL. HDL. These are Verilog, Verilog, and next VHDL, and next we have SystemVerilog, SystemVerilog. Okay, so these are HDLs. Okay, so VHDL is nothing but very high speed integrated circuits, hardware descriptive language. Okay, so here, what is the difference between the software languages and hardware descriptive languages? Means the software languages we can only develop the application. They can only develop the application. Okay, so they can develop the application and they can give it to some bank related application or like ticketing, airplane ticketing, and related to like stock market software. They will develop the software and they will give it to given required client. Okay, hardware descriptive language means like there is a term called synthesis. So synthesis by using this hardware descriptive language, we are describing. You already studied the digital, so digital like combinational and sequential circuit. You are describing the hardware in terms of textual format is nothing but hardware descriptive language, and we can convert your program into hardware. We can convert whatever the program into hardware. That is nothing but that is the main difference between software language and hardware descriptive language. That is HDL. Okay. We have VHDL. So VHDL means I told you very high speed integrated circuit hardware descriptive language, and this is highly secure. Okay, highly secure, and this is came into mainly it is used in defense and academics. Okay, and it consists of like hard syntax. It is hard syntax. Okay, hard to learn, and so it will follow the old language like Ada and Pascal. Ada and Pascal, old language. Okay, the program will be very complex. Okay, this came into like standardized around 1999. Okay, this VHDL standardized as 1999, and next is Verilog. So Verilog, so we can by using this Verilog, we can like design. That means 90% we can design, but 10% we can verify only. Okay, so mainly it will follow C syntax, C syntax. Okay, easy to learn, easy to learn. Okay, if you know the C language, then you can easily learn the Verilog, and and this came into, this is standardized around 2001. Okay, 2001 it is standardized. Okay, and next is SystemVerilog. SystemVerilog, this is mainly nowadays the designers are using SystemVerilog for designing purpose only. So designing and verification. 30% it is for designing, designing, and 70% or around 90% they are using for verification. So whenever you are writing the code, you need to verify that your your circuit is working properly or not. Suppose we already seen the like full adder circuit. Okay, so full adder circuit with the truth table. Okay, this is with the truth table. I verified. I got sum equal to A XOR B XOR C and carry equal to AB plus BC plus C. With truth table, I verified. But programming, by applying the programming, how to verify this? Okay, so how to verify this? This means you want some verification language, and system Verilog we are using for verification. But if you want to write verification for I2C separately, again if you want to write for verification test bench, you are writing the test bench only for verification. So if you want to write test bench for UART, separately you need to write. Okay, there is no standardized test bench is not there, so that's why you are going for UVM. UVM is nothing but universal verification methodologies. This is not a language, this is a methodology. You are using SystemVerilog in the UVM, and some means already you wrote the test bench for UVM. With some modifications, you can write the write the test bench for UART. Okay, that is the main that is standardized. Any company they will write the test bench by using this UVM. Okay, so this is about the introduction. Hope you understood. Any doubts or queries? Shall I move forward? Anyone give response? Hello. Okay, yeah. One second. Yeah. Next, so that means Verilog code I told you, no? So Verilog code, you have, so you have a Verilog code, okay? Verilog code. You are writing the code so for this writing the code, you need some EDA tools, okay? So you have a Verilog code, and with the help of some EDA tools like Xilinx Vivado or Model Sim, okay, or Quartus Prime, okay. So by using this electronic design automation tools, you are writing the code, okay. And what these EDA tools will do, EDA tools will convert whatever your code into gate level netlist. Gate level netlist. Gate level netlist is nothing but your code is in terms of gates. Okay, so that means you are describing gate level netlist is nothing but you are describing your describing in terms of gates. In terms of gates. Okay, that is nothing but gate level netlist. Okay, so that means converting your code into gate level netlist is nothing but synthesis. Okay, this is very important. What is synthesis means? Converting your code, the code that is HDL code, whatever the HDL hardware descriptive language HDL code into gate level netlist. Gate level netlist netlist is nothing but synthesis. This is nothing but synthesis. Okay, synthesis. Nowadays they are using C or C++ for the this is for writing the code into hardware HDL. This is nothing but we call as high level synthesis. High level synthesis. So mainly in the RTL design, we are writing the Verilog code only. And next, coming to the representation of design. Okay, so in the Verilog, representation of design. Okay, representation of design. So mainly this is nothing but abstraction level. So mainly it is represented first in what we call uh, uh, switch level modeling, switch level modeling, switch level modeling, and next is gate level modeling, gate level modeling, and next is data flow modeling, data flow modeling, and next is behavioral modeling, behavioral modeling. Switch level modeling is nothing but you are representing. your circuit in terms of CMOS circuits. That means this is low level modeling. You are writing the code for this low level modeling. That is nothing but switch level modeling. And gate level modeling means you are writing code in terms of what in terms of gates. Okay, in terms of like uh, let us take like suppose the AND gate is there. So AND gate means with the gate level primitive you are representing. Okay, so A B and Y equal to this is A and B. Okay, so Y equal to A and B means that there are some gate level primitives are there like AND or not. Okay, these are the predefined gate level primitives are there, and nor. Okay, so here the syntax will be like gate level primitive, gate level primitive, and next gate level instance. So the instance gate level instance followed by output and inputs like this. It will be there. Okay, so means so suppose if you want to write for AND gate, what is the gate level primitive? AND is my gate level primitive. Okay, and A1, and what is the output of Y comma A comma B? Like this you need to represent. Okay, and next, data flow modeling means you are representing in terms of expressions. Suppose you are using a continuous assignment statement, that is assign. Okay, assign y equal to what a and b. This is nothing but bitwise logical operator. Okay, these operators will discuss. Okay, so y equal to a and b. Okay, this is a data flow modeling. Behavioral modeling means like suppose example, if you take the half adder circuit or a full adder circuit. Okay, so half adder circuit, I know the behavior of the circuit. Okay, that means it consists of two inputs and two outputs, sum and carry. I know, and no need to, I will not bother about this what we call inside circuitry. So I will only bother about the behavior of the circuit. That is nothing but behavioral modeling. Okay, so that is nothing but behavioral modeling. And so mainly that is RTL. RTL is nothing but register transfer level. So mainly it will shows how the data is transmitting through the registers is nothing but RTL. Inside that will be converted into in terms of D flip flops. Okay, so that means mainly that means synthesis. So when you write the RTL code, this RTL will be converted into gate level netlist. Gate level netlist. Okay. So gate level netlist. So mainly, you should write the code in terms of data flow modeling and behavioral modeling, or we can write in hybrid modeling also. Hybrid means both data flow as well as behavioral modeling. That is nothing but hybrid modeling. Okay. So that is this is about the switch level modeling. Just I will give a clear explanation of this. One second. One second. Yeah. See here, just this is a VLSI design flow specification RTL and GDS. So GDS is nothing but a graphical data system that is layout and IC. Okay, this is integration. So HDL is nothing but hardware descriptive language. It is easier to describe the means describe the digital system. Okay, in terms of hardware, there are some CAD tools are there. Okay, CAD tools. By using these CAD tools, we can write the Verilog code, and we need to make an IC such a way that whatever the it should take low power, high performance, and low power consumption at low cost. Okay, so this HDL serves as a platform for design entry as well as verification, synthesis, and analysis. Okay. Uh, so that means many features of HDLs are same as C or C++, but there is some additional features are there. That is nothing but concurrency. Concurrency is nothing but parallel execution. This is nothing but parallel execution. Okay. HDL must support some syntax and semantics that we'll discuss. Okay. So level of abstractions I told you, like It will support so mostly like there is top-down approach and bottom-up approach. Okay, bottom-up approach means it will start from circuit, gate, modules, and system. Okay, circuit means in terms of you are writing in terms of CMOS. Okay, gate means like you are in terms of gates. You can design in terms of circuit. You can design the gates. Okay, in terms of gates, you can design the modules. In terms of modules, you can design the system. Okay, so there are like types of abstraction: circuit level abstraction, gate level abstraction, data flow, and behavior. So this is nothing but we call as RTL level. Okay, RTL level. So, so that means if you see, so transistor level is nothing but switch level modeling. We'll write the code for transistor level, that is nothing but switch level modeling. Okay, gate level modeling means we'll represent in terms of logic gates or flip flop, that is nothing but gate level modeling. Okay, and register transfer level means you have two types, that is RTL and behavior modeling. So data flow modeling and behavioral modeling. Data flow modeling means you need to use a continuous assignment statement, that is assign E equal to B plus C. Okay, in the behavioral modeling, you need to use, we'll discuss in detail, that is procedural blocks. Okay, so that means it consists of some procedural statements. Uh, there are mainly initial block and always block. Okay, initial block is non-synthesizable. Initial block is non-synthesizable, but always block is synthesizable. Mainly for the RTL code, we are writing the in always block, but in the test benches, we are writing in initial block. Okay, and there are some procedural statements in the behavioral modeling. Those are nothing but if, case, for, or while. These you already studied in C language. Okay, if, else. Okay, these you already studied. And procedural are assignments also, blocking assignments and non-blocking assignments. Okay, blocking assignment means when one instruction will be executed, next instruction will be in blocked state. That is nothing but blocking assignment. And non-blocking means all the executions, all the instructions will be executed parallelly. That is nothing but non-blocking assignments. Okay. So this is the program structure. It will start with the module and module name, port list declaration. Okay, and end module. Okay. So this is the basic program structure. The Verilog code will start with module and end module. And this is switch level modeling. This is the example. First level modeling I told you, that is switch level modeling or circuit level modeling. It consists of NMOS and PMOS. NMOS and PMOS. Okay. So how you are representing, that means syntax is NMOS, instance name, out to data and control, like this. Okay. NMOS, and what is the instance name? N1. What are the output drain? For NMOS, what is the output? Drain is the output, and the data is source, and control is gate. Okay. Suppose if you want to write the code for inverter, how to write the code for inverter? So this is A and A bar, and this is the CMOS implementation for inverter. Okay. So module and module name. What is my module name? Inverter underscore gate V in V out input V in, output V out, supply 1 VDD, supply 0 with ground, and I need to write separately for instance for PMOS and instance for NMOS. Okay, how we are writing PMOS. For PMOS, what is the output? V out is the output. V out is the output, and what is data? VDD, and what is the input? V in. Okay. For NMOS also, V out is the output, and ground is data, and V is the control pin and end module. Okay. So this circuit level modeling we are not preferring. Why? Because when you are going for large level SOC design, okay, this one we can't prefer. Okay, we can't prefer this one. Okay. So gate level modeling means you are using, as I told you, you are using gate level primitives, okay, ready to be instantiated. So what are the gate level primitives? And, or, not, NAND, NOR, XNOR, buff1, buff0. These are the gate level primitives. Okay, so this is the syntax: primitive name, instance name, output, input 1, input 2. Okay. Suppose if you consider the half adder. Half adder have how many? That means one XOR gate and one AND gate. Okay. How to write the gate level modeling? So that means module, and what is my module name? half adder underscore gate 1. Output you need to declare output sum comma carry input a comma b. XR sum comma a comma, this is the output and these are the inputs. Okay, and carry a comma b. Okay, or like this also you can write. That means primitive name, that is XR, and instance name G1 sum comma a comma b, and G2 carry comma a comma b. Like this you can represent. Okay. RTL means you are writing in terms of data flow modeling and behavioral modeling. Same half adder if you take. Okay, how to write a module HA underscore data flow A comma B comma sum comma carry. So this is a port list declaration. Input A comma B, output sum comma carry. And it uses a continuous assignment statement, that is assign sum equal to A XOR B, carry equal to A and B. Okay, this is nothing but data flow modeling. Behavioral modeling means I can use case statements, if else statement. Okay, these are nothing but procedural statements. Okay, and I need to write between the procedural blocks. I need to use always. Okay, half HA underscore behavior. Port list declaration I can declare within the bracket input A comma B. And remember, when you are using behavioral modeling, output should be rich data type. That data types I will tell you, don't worry. So always at the rate, this is sensitivity list, begin, case A comma B, two tick binary 0 0. Okay, based on the truth table only. Okay, so A, B, and sum comma carry. Okay, so in digital you already studied 0 0 0 1 1 0 1 1. Okay, sum 0 carry 0, sum 1 carry 0, sum 1 carry 0, sum 1 carry 1. Okay, so that means 0 0 means what, sum 0 carry 0, 0 1 means sum 1 carry 0, 1 0 means sum 1 carry 0, 1 1 means sum 0 carry 1. For case statement there will be default statement. Why it is default statement I will tell you. This is behavioral model. Okay. Hope you understood all these modules, switch level modeling, gate level modeling. Any doubts or queries? Shall I move forward? But if those gate level modeling means, suppose if you are going for, suppose if you want to design RAM, okay, RAM, suppose a complex circuit is there. So with gate level modeling, it is difficult, no? Suppose if you consider some complex circuit, so this circuit is there. Suppose this AND gate, and it is given to one OR gate. Again, this output is given to one XOR gate. Okay, and again this one is given to one more XNOR gate. Some complex circuits are there. Means the program becomes lengthy. We should write a program such a way that program should be as short as possible. It should be it should take less amount of lines. Is it fine? Means I told you, no, RTL design. RTL design means we can write data flow modeling and behavioral modeling, or mixed hybrid modeling also we can write. Okay, but switch level modeling, data flow, gate level modeling, we are not preferring. Okay, yeah. Next, basic syntax. Basic syntax if you take. So Verilog will start with the basic module, and there are a module and end module. Okay, these are nothing but what, keywords. Okay, if you Google it, how many keywords are there in the Verilog? Means you are getting around 150 keywords are available. Okay, so these are nothing but keywords. Okay, suppose if you want to write the code for half adder. Okay, so if you want to write the code for better, just 1 minute. My charging. Suppose if you consider half adder circuit, how many inputs are there? Two inputs are there. Okay, A and B, and how many outputs? Two outputs, sum and carry. Okay, so how to write? So that means a module, and HA. Okay, HA. So module is nothing but this is a keyword. This is the keyword. Okay, and next this is identifier. This is identifier. Okay, and port list. Port list means what? I need to declare the port list. Okay, port list means so here A comma B comma. So let us take this is capital A comma B, A comma B comma sum comma carry. Okay, sum comma carry, sum comma carry, sum comma carry. Okay, so that means here semicolon will be there, and end module. It will end module. Okay, here no semicolon, no semicolon. Okay, no semicolon. Okay, this is the uh, basic program structure, and rules for identifiers. Rules for identifiers. What are the rules for identifiers? So that means you have invalid identifiers, invalid identifiers, and valid identifiers, valid identifiers. Invalid identifiers are nothing but suppose for the half adder I'm writing. Okay, so that means H space A. Okay, or it should not start with number 2HA. The compiler will not take. Okay, 2HA and 2H space A, and next dollar HA. Okay, and next H hash A. This will not take. Okay, so that means what are the invalid identifiers? Means we cannot use a special symbol. We cannot use special symbol, special symbols. Okay, and special characters. Okay, so special characters, and next numbers at the starting position, numbers at starting position. Okay, and gaps between there is a space, gaps between, it will not take. Okay, suppose underscore it will take. Suppose 2 cross 1 mux is there. Okay, I want to give the identifier name. I can give underscore 2 cross 1 mux. I can give like this. Okay, so I can give, the compiler will take. Okay, so like this. Okay, so valid identifier, so HA. Okay, next H small a, HA2, HA2, and underscore HA, HA underscore, H underscore A. Okay, these are the basic syntax, basic rules for the identifier. Is it fine? Any doubts or queries? Shall I move forward? Okay. Okay. Yeah. Next, port list declaration. Port list declaration. How to declare the ports? Here, if you see that there are two styles are there. style one. So style one is module HA. You can declare the inputs and outputs. So this is EAB, sum comma carry. Okay, and here I can declare input A comma B and output sum comma carry, sum comma carry. This is style one. Okay, style two is style two is module module HA. I can declare the inputs and outputs within the bracket itself. Okay, end module. Okay, this is end module. End module. And here I can declare the inputs and outputs within the bracket itself. Input A comma B and output sum comma carry, sum comma carry and end module. Okay. So these are the two styles of representing. Is it fine? So these are the two styles. Mainly we are using style 2 only, but style 1 means the number of code length will increase, no? So style 2 only we are representing within the bracket itself. Okay. And there is a dollar display. There are some system tasks we'll discuss. Okay, this is nothing but system task. Any thing start with dollar is nothing but system task. So dollar display is nothing but it's like a printf in C language only. So whatever you are writing, that will be displayed. Okay, so in dollar display there are some escape identifiers like blank space. Okay, blank space, you can write backslash b or tab. Okay, tab you can write backslash t, and new line you can write backslash and like that you can write. Okay, and next you have the comments. Okay, so you have the system tasks like a dollar display, dollar monitor, dollar strobe, dollar finish, dollar stop. Okay, that we'll discuss when we discuss the system task. This is introduction only. These comments are nothing but these are used for increasing the readability. Okay, increasing the readability. That means what that instruction is doing. Okay, so we can understand the line. Okay, for understanding the lines. Okay, what that instruction is doing, that is nothing but comments. Okay, there are two types of comments. That is nothing but suppose uh, single line comment, single line comment. Okay, single line comment is nothing but like the syntax will be like this. It will be uh, two slashes. Okay, so you can write SLC. Okay, uh, so like this you can write. Okay, this is single line comment. Okay, and multiple line comment. Multiple line comment means here you have slash star and multiple line comment. Okay, multiple line comment. So there are multiple lines, and this will end with the star slash. Okay, and nesting is not allowed. Nesting of comments is not allowed. Nesting is not allowed. Nesting is not allowed means comments under comments. This is a comment. One more comment. Again within this one more comment. Okay, nesting of comments is not allowed. Okay, compiler will not take. Is it fine? Okay. Yeah. Next, you have basic constructs. Basic constructs. Okay. Number specification in Verilog. Number specification in Verilog. So here, how you are preferring, that means in digital you already studied like binary number system, which is having base or radix 2, okay, and next octal number system, which is having octal. So octal base is 8, okay, base or radix is 8, and next you have decimal number system having the base is 10, and hexadecimal number system, hexadecimal number system. The hexadecimal number system having the base 16. Okay. Suppose if you take the binary number system, so first we'll take the binary number system. Binary number system. Suppose if I want to represent 0011, okay. So the syntax will be like this. The syntax will be size, tick, base, and value. Base and value. Okay. So size is nothing but number of bits. Number of bits. Okay. Base is nothing but base of a number. Okay. Base. If it is binary, you will represent small b, and octal means small o, and decimal means d, and hexadecimal means h. Okay. Suppose if I want to represent 0011, okay. So how I am representing, how many bits are there? 4 bits are there. Okay, 4 tick, this is binary, 4 tick binary, and my value 0011. Like this I will represent. Suppose one more 8-bit number is there, 1111, and 4 zeros are there. So how I can represent, that is how many bits are there? 8 tick binary, 1111, 0000. Like this I will represent. Is it fine? Shall I move forward? Okay. Next, octal is there. Octal. Octal number system is there. Octal number system, so which is having the base 8. So base 8, suppose 822 to the base 8 is there. Okay. 822 means, is this a valid octal or not? Just tell me. Anyone? Why? Suppose any number system is there. Yes, number system having the radix r, this range is what? 0 to r minus 1. Okay. So that means during the conversion, they are asking that convert this octal to decimal, means you are doing means, so interviewer will understand that you don't know the range. This is not a valid octal. You need to tell not a valid octal. Why it is not a valid octal? Again you will ask. Why? Because the range is 0 to 7 only, but you indicated 8. This is not a valid octal. This is one interview question. Okay. So 722 to the base 8 is there. So how we are representing? That means the size, the base, and value. So what is the size? What is the size? So normally compiler it will convert into binary only. So that means this is having the radix 8. So how we are representing 2 cube, no? So you want to represent 3 bits. This is nothing but 0, 1, 0, and this is nothing but 0, 1, 0. Okay. 9 tick binary, 9 tick octal. What is the value? 722. 9 tick octal 722. Okay. Okay. Like this you will represent. Okay. Suppose 55 to the base 8 is there. Okay. Can you mute yourself? Someone is talking. Yes. Hello. Hello. Somebody is talking. Can you mute Dheeraj Sharma? Yeah. Next you see 55 to the base 8 is there. You want to convert this one into octet. So 55 you are representing 101 and this is 101. So 101 means you can represent 6 tick octet 55 like this you can represent. 8 tick also you can represent. That means if you are adding two more zeros, 8 tick octal 55 like this you are representing. Okay. This is octal, and next is hexadecimal. Hexadecimal. So hexadecimal, which is having the base 16. So FF1 is there. So FF1 to the base 16 is there. So how we are representing? So convert this one into binary. So not internally it will convert into binary only. So this is 4 ones and this is 4 ones and this one is 0001. Okay. So how many number of bits are there? Size is dual tick H HFF1 like this. Okay. Similarly, decimal is there. Okay. Decimal how we are representing decimal. Decimal means this is having base 10. 53 is there. 53 to the base 10 is there. So 53 to the base 10 means I need to convert into binary. Okay. So we are converting 1, 2, 4, 8, 16, 32 and 64. The number lies between this one. 53 minus 32. Okay. 32 means, so that means from here I can say that how many number of bits the number lies between 64 and 32. So it will take how many number of bits 1 2 3 4 5 6. Okay, so I can write 6 tick decimal and 53, 6 tick decimal 53. Okay, so like this we will represent. Suppose suppose if you take the binary number, uh, let us take tick binary 0 1 1 0. Okay. Can anyone say what is the size of this? I not included the size. Size is missing. Size is missing. What is the size? Can anyone? 4 bit. Okay. Next. 4 bit is a not correct answer. So this is 32 bit. This is nothing but 32 bit. Okay. Most of the compilers are 32 bit only. Okay. So most of the compilers are 32 bit. Okay. 32 bit. Okay. So compiler will take the size of 32 bit and default size is 32 bit only. Suppose if you take the octal number also 0 O tick O 73 is there. Okay. So what is the size? You not included any size. This will take 32 bit. Okay. And tick H 55. Tick H 55 means what is the size? Size is 32 bit. Okay. And let us take 0 1 is there. You not mentioned any size and you not mentioned any base. How it will take? What is the size and what is the base? 32 is size. Okay. 32 is blindly it will allocate the size is 32 bit. Okay. What is the base? 23 I will give. 69 I will give. What is the default base? Default base is decimal. Default base is decimal. It will take as decimal only. To avoid the confusion, it will take compiler will take the default base as decimal only. This you need to remember. Okay. These are some interview questions. They will ask the interview questions. Okay. Is it fine? Any doubts or queries? Next, special characters. Special characters. So you have the special characters like X. X is nothing but don't care, or unknown, unknown. Okay, so in digital we already seen what is the value of don't care, 0 or 1. Okay, and Z is high impedance, high impedance. Okay, high impedance, and so high impedance is nothing but just not connected. We already seen in the analog part Z, no. So this is nothing but not connected. This is high impedance, high impedance. Okay, and strings in so here you have strings. Strings are nothing but it's a sequence of character enclosed in the double quote. Sequence of character enclosed, okay, enclosed in double quotes, double quotes. So like we'll call like nanodaya. Nanodaya means each character will take 8 bit. Okay, each character will take 8 bit. So how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 8, so total 72 bits. Okay, so like this it will store. Okay, and next you have the value set. So Verilog will support 4 value set. So that means 0. 0 is nothing but logical low or false condition. Logical low or false condition. And 1 is nothing but logical high or true condition. And next x is nothing but don't care. And z is nothing but high impedance. High impedance. Okay.